Hello all. In this session, I'm explaining you about Findus algorithm. First, let us see what the problem statement says. In the problem statement, they have given for a set of training data examples stored in a .csv file, implement and demonstrate the Findus algorithm to output a description of the set of all hypotheses consistent with the training examples. What the problem statement says is we have to consider a CSV file, and for that data we need to implement and demonstrate the Findus algorithm and to output a description of the set of all hypotheses, and whatever the set of hypotheses we get, that should be consistent with the training examples. So this is what the problem statement is saying. We need to implement a Findus algorithm using a CSV data, and finally we should come up with one hypothesis that is consistent with the all positive examples. Okay, and before getting into the algorithm or the code, first understand the basics of Findus algorithm. So basically, Findus algorithm is a basic concept learning algorithm in machine learning. We can say Findus algorithm is one of the basics of machine learning where it helps to learn the data. And the Findus algorithm finds the most specific hypothesis that fits all the positive examples. Here, what Findus algorithm is doing is it is going to find one most specific hypothesis so that it is going to fit into all the positive examples. We have to note here that algorithm considers only those positive training examples. Here, what we should keep in mind is we are not supposed to consider the negative training examples. Only the positive training examples has to be considered. And find this algorithm, it starts with the most specific hypothesis. To start with this algorithm, we have to consider the hypothesis which is most specific and generalizes this hypothesis each time it fails to classify and observe training data. Here, how the algorithm works is first we should start with the specific hypothesis, and based on the positive examples, we should keep on changing the hypothesis to more general. And finally, what we get is most general hypothesis. With one example, you can clearly understand this algorithm. Okay, before getting into that, we will see some of the basic important representations to learn this algorithm. One is the question mark. Here, the question mark indicates that any value is acceptable for the attribute. If you substitute any value, the place of attribute with a question mark, then what it says is, yes, you can substitute it with any positive attribute. Next is specify a single required value for the attribute. Okay, and what it is saying is one attribute you can specify in that place. Next is null. What null indicates is that no value is acceptable. What null is saying is you cannot substitute any value. And here the most general hypothesis is represented in this format. That is, we are using question mark. If all the attributes of the hypothesis is substituted with a question mark, then it becomes the most general. And if all the attributes are substituted with a null, then it says it is the most specific hypothesis. And what the steps involved in Findus algorithm? So what are the steps? As I told you, we need to first initialize the hypothesis with the most specific values. That is, we have to take all the null values there. That is, to start with, hypothesis looks like that, like this. Then what we should do is we have to consider the data set, whatever we are dealing with, then we should keep on checking. If the sample is positive, we should try to check the hypothesis with the existing hypothesis. If both the things matches, yes, fine, we can retain the hypothesis. And if it doesn't match, then we need to replace that with the question mark. If that sample or the example, whatever we are considering is negative, then we should not at all consider that example. This thing you will understand clearly with one example. Okay, here I am considering this data. This data is about classifying a seed as poisonous or not poisonous. So here we have 7 samples. We call this as 7 samples or 7 examples. And these are the attributes: color, toughness, fungus, and appearance. We call this as features or attributes. And based on these attributes, we can say whether the seed is poisonous or not poisonous. Here, what the first example is saying, that color is green, toughness is hard, fungus, no fungus, appearance, it is wrinkled. So, what is the output? Here we got is, yes, it is poisonous. That means it is positive example. In the next example, what you can see, it is color is green, toughness is hard, yes, fungus is there, yes, appearance is smooth. And what is the output you got there? It is non-poisonous. The answer we got, the prediction we got is no. So we cannot consider this for generalizing the hypothesis. Okay, we will check. This is considered as whatever the result, if it yields as no, is considered as negative example. If the result it is yielding yes, then we consider that as a positive example. And coming to the steps. So what is the steps? It is involving, as I told you, first of all, the first hypothesis what we should consider is this null hypothesis. Null hypothesis is nothing but it is the most specific hypothesis. Then we should consider the first example. So what is this first example saying here? That first sample is yes, that is positive. And you should check the features. Here we are using the null hypothesis. That is all the values attributes are null. So what we are doing? We are changing the hypothesis to the existing values. What is it? We are replacing null with green, hard, no, wrinkle. This is the first hypothesis we got. Consider the example 2. Their outcome is no, that is negative outcome. So hypothesis remains the same. Again, consider example 3. There also it is giving negative outcome. So hypothesis remains the same. And next consider example 4. There what we have in example 4, that is yes, it is positive. Now you should check with the attributes. Here what is the attribute? That is color is orange. But according to our hypothesis, color is green. Here both the things are different. So what we do is we just replace with the general hypothesis, that is general value, that is question mark. Then you check with hard and hard. Yes, both are hard. No and no, and both are same. Wrinkled and wrinkled, both are same. No need to replace the values, that is no need to replace the attributes. Now what the hypothesis has become? H is equal to question mark, hard, no, and wrinkled. And next you consider example 5. And in example 5, you can call this as example or sample. Okay, in sample 5, it is yielding yes. So what does it mean? You need to check with the current hypothesis. So here you just compare with the attributes. What is it? We have question mark there. And again, the color is green and we have already replaced with the question mark. You can retain that. Next, you have soft and hard. So soft and hard both are different. Instead of that, what we are doing, replacing with general value. Yes and no, yes, replacing with general value. Wrinkled and smooth, yes, replacing with the general value. Well, for example, 5, it yields to most general hypothesis. What the hypothesis has become now? That all the values are, all the attributes are replaced with what? Question mark. So what does it mean? You can substitute any attributes to this value. So this is how the finders algorithm works. And why we use this algorithm? It is used to classify the data in a more efficient manner. See, if we train a machine by using these kind of data, by using finders algorithm, what it will do? It will categorize all the positive samples. It will frame a positive hypothesis so that whichever the new data comes in, it is like it makes the examples to fit into the hypothesis properly, and also it helps to classify the samples in a better way. Okay, so this is how finders algorithm is has its own importance in classification. And next is, this is the algorithm. As I have mentioned, first thing is we should go with the most specific hypothesis by using the null values. Next is, for each positive training instance X, for each positive instance means if that sample is positive, yes. For each attribute constraint A in H means in that hypothesis, for all the attributes, if the constraint A is satisfied by X, if the attributes of hypothesis and the attributes of A both are attributes in the hypothesis and attributes in the instance X both are same, then you should not do anything. That is what we did, right? If both the values are same, we should not replace that with question mark. If it is positive sample, and if that attribute is different, then you should change that with the question mark. And finally, what happens is you will get a hypothesis which is general. And here is the code. I'll explain you this code with by executing that. Okay, and for that I'm using Jupyter Notebook. And here in this code, what we have is initially I'm importing pandas and NumPy libraries from Python. Pandas is used to read the data and NumPy is used to deal with the arrays. And here we are importing pandas as PD because that is the short form of pandas. Instead of using pandas everywhere in a program, we are using PD that as a short form, same way NumPy. Next, after that, we are reading the we should read the data here. That is, data is equal to pd.read CSV. I'm importing the data, and the data is about, see, the data is like this. Data is about weather condition, and based on that weather condition, a person is going to decide whether he can go out or not. Okay, that is what the data is saying. See, here we have weather, and if it wind, all different attributes we have here. I'll show you here itself. See, we have time, weather, temperature, company, humidity, wind. So that all these attributes makes a person to decide whether to go out or not. Okay, and here what I have is uh, yeah, I have stored it as a CSV kind of data in one Excel sheet. That is, Excel sheet supports CSV kind of data. So there I have stored that data set. And next is, whatever the data it is reading, that has to be printed. And that is what I'm making. See here. After reading the data, it is printing. So first step is that. And next is np.array data. So what I'm doing is I'm importing, importing the data into the array. So these are the data. It is imported into the array, and again I'm printing that. Next is I'm printing the target value. What is the target value? That is the final values, whether it is yes, no, like that data, final outcome. That is the target. I'm printing the target value as well. And here comes the main logic of the program. Here I'm defining a function called train. Inside that I'm passing the parameters. One is C, another one is T. And here one says the hypothesis, C is the attribute, and you will check if it is positive, yes. And if the values are, if the attribute values in the hypothesis and the example both are same, then you keep it as it is, how as it is, like that. Okay. Next, you have to check if it is not same. If both the attribute values in the sample and the hypothesis are different, then you should replace that with a question mark. And finally, you are after completing all the examples, iteration of all the examples, you end up with a specific hypothesis, and that I'm printing finally. And for this example, for this data set, this is the final hypothesis I got. And here what it is saying, that first attribute is replaced with question mark, second attribute sunny is only retained, and next third attribute is replaced with a question mark, like that the hypothesis has become more general. And this is about Findus algorithm. Thank you.